Okay. Okay, so let's get started. Right, so we are getting into a different kind of function, a different kind of transcendental function, the so-called trigonometric functions. Right? Trigonometric functions. Okay, so the way we're going to introduce them is by using the unit circle. So there's kind of two ways to talk about the trigonometric functions. One is with triangles, and one is with the unit circle. And these are sometimes called the circular trigonometric functions to distinguish them from another set of trigonometric functions called the hyperbolic trigonometric functions, which are based on the unit hyperbola. Okay, but in any case, we're going to be talking about them from the point of view of the unit circle, because that's actually, from a mathematical point of view, that's actually their natural home. That's kind of like the right way to introduce the trig functions. Okay, so in order to get there, we're going to have to first talk about this thing called radian measure. How many of you have seen radian measure before? Radian measure, sort of. Okay, so some of you have and some of you haven't. It's just a way of measuring angles. So like a way of describing angles. A way of describing angles. Okay, so I think probably the way that you're most familiar with is to say that a circle is 360 degrees, right? So you're used to the method of the measure using degrees as your measure, where a circle is 360 degrees. But there's a kind of more natural way of describing angles that mathematicians like, and I think scientists like, and that is to describe them using these things called radians instead of degrees. So we're going to basically get rid of degrees and replace them with these things called radians. Okay. Why? So from a mathematical point of view, the way of describing a circle as 360 degrees is kind of strange, right? Because if you showed this to a kid and said, we call this 360 degrees, and the kid said, why do you call it 360? I think there's no real good answer to that, right? Where's the 360 on here, right? Why not call it 100 degrees or 1,000 degrees or 10 degrees, right? Why is this? Where does the 360 come from? Does anybody know where the 360 comes from? I think it's historical. It probably comes from the days of the year, right? It probably comes from the number of days in the year. The ancient Egyptians believed that there were 360 days in the year, and then 5 extra days that were given to the goddess Isis in order. No, not the goddess Isis. I forget. I think it was Isis who was not allowed to give birth to her children during the year, and so she, there was some arrangement between her and the god of time, who added 5 extra days on, and then she was able to give birth to 5 children on those 5 extra days. Okay. Anyway, so in any case, this 360 has to do with maybe the days in the year, probably the days in the year. In other words, it's an astronomical thing, not a mathematical thing, right? It has to do with our solar system, not with mathematics itself. Okay, so like, if that, if they're an alien from another planet, maybe that 360 wouldn't make sense to them, right? Okay, so radian measure is something maybe more mathematically natural. Okay, so in this degree system, you say, okay, we're going to count the whole circle as 360 degrees, and then for example, something like this would be 90 degrees because it's a quarter of the 360. right? Something like this is 45 degrees because it's an eighth of 360. Everything is related back to that 360, which was sort of like a strange number to start off with. Okay, okay. So radian measure, in radian measure, how do you describe an angle? How you describe an angle is like this. So you say, okay, if I have an angle like this, so here's my angle, let's call it theta. Okay. What you do to describe the angle is say, okay, suppose this is a unit circle. Suppose this is a unit circle. Look at the length of the arc that is subtended by this angle. Okay, look at the length of the arc that's subtended by this angle. The arc that's sort of captured by this angle. Okay, and that's going to be some length, right? So this length is the arc length subtended by the angle theta. Okay, and we call that, then we're going to call, we call theta s radians. Okay, so it's just the length, it's what, the number that we assign to theta is the length of the angle, I'm saying the length of the arc subtended by the angle on the unit circle. Okay, subtended by the angle on the unit circle. Okay, so for example, like if we're talking about the whole circle, right? Well, then we'd be talking about the length of the circle, right? On the unit circle. Well, what's the circumference of the unit circle? What's the circumference of the unit circle? The length of the whole unit circle, you guys?
Pi times the diameter.
Yeah, so 2 pi, it's 2 pi, right? Pi times the diameter, or 2 pi times the radius, you know, 2 pi times 1. Okay, so this whole thing is going to be called 2 pi radians, right? The whole circle would be called 2 pi radians, not 360 degrees. Okay, instead of 360 degrees, right? Or if we were talking about an angle like this, right? Our 90-degree angle, what would that be in radians? Well, you have to look at, if we're on the unit circle, you look at, you know, how much is captured by this, right? How much of the unit circle is captured? Well, what's the length of that thing? Pi over 2, right? Because the whole thing is 2 pi, right? And this is a quarter of that, so it's going to be, you know, a fourth of 2 pi, right? In other words, pi over 2, right? So this is pi. This angle here is pi over 2 radians. Right? Right? You know, if it were, say, you know, a 270-degree angle, right, then it's going to be 3 pi over 2 radians. Right? If it's a 180-degree angle, then, you know, it's going to be pi radians. Okay, does that make sense? Okay, so this is maybe more natural. Like if an alien from another planet came and said, "What do you call, you know, what do you call this angle?" You'd say, "Well, we call it pi radians because on the unit circle, the length of this is pi. The length of this arc is pi." Right? We name the angle by the length of the arc on the unit circle. Okay. Right. 45-degree angle. Right. 45-degree angle would be, you know, pi over 4. Right. Half of the 90-degree angle. and so on and so forth. So, if you don't want to think about the unit circle, you can always just think, okay, we think of this whole thing as 2 pi radians, right? You can sort of go back to your method of relating everything back to a number, right? A number, an arbitrarily chosen number. The difference is that this number actually has a meaning, has a mathematical meaning, namely the length of the circumference. Okay. Everybody okay? Any questions? Okay. Okay. Let me just make one comment. You can think of this, suppose you have a circle suppose you have a circle that is of radius r, and this arc length is s. Okay. So this is not the unit circle anymore. Okay, suppose you have and you know the arc length here, and you're wondering, what's the angle? What's the angle, right? Well, so what you have to do is, well, one way of thinking about it is, you could say, okay, let's put a unit circle inside there, right? And figure out this length, right? That length is going to be the angle in radians, right? Let me give you a minute to see if you can figure out what if you know the arc length and the radius, what's the angle in radians? So if you know arc length is s and the radius is r, what's the angle in radians? Okay, turn to somebody nearby and talk with them, please. Okay, so so we're trying to figure out what this angle is in radians, right? To do that, we need to figure out the arc length that's subtended in the unit circle, right? So how do we figure that out? We know, yes, anybody? Anybody have an idea? Shy? Jane.
I have an idea.
Yes.
Would it be 2 pi r over s?
Let's see. So let's think about so 2 pi r. 2 pi r is the total, is this full radius here, right? 2 pi r is that full radius, and then if you divide that by s, that's basically saying like that's the ratio of the total to this thing. Right, the ratio of the total thing to this arc, and we want to figure out what this thing is here. So anybody see? We can use that. We can use that ratio, right? I think for me it'll be a little bit easier to understand if we do it this way, right? We say s over 2 pi r. That's what percentage this arc takes of the whole thing, right? Okay, so we want to figure out this thing, right? We know what's the whole length over here? What's the total length here? This thing here is the percentage of the percentage that S is of the whole arc. The whole circle, sorry. Right? So it could be like a fourth, say, right? It looks something like a 12th or something. Okay. So now what's the length here? What's the total length here? 2 pi, right? So the length of this thing is going to be that percentage of 2 pi, right? So you say, okay, right? S over 2 pi r times 2 pi is going to be that thing we're looking for, right? Or maybe this makes it easier. You say, well, look, the ratio of s to 2 pi r is the same thing as the ratio of question mark to 2 pi, right? And so question mark is going to be 2 pi times s over 2 pi r. Right, so that tells us that that question mark is going to be s over r. Right, so this thing here is s over r. Okay, so right, so that gives us this nice relation, right? That the angle is the arc length over the radius. So in a circle of radius r, the angle is s over r, where s is the length of the subtended arc. Okay, so that's kind of a nice formula for the general circle. Right, for the unit circle, you see that the angle is just going to be the arc length. Right, the angle is s over r in the unit circle. The angle is actually just the arc length, and that's how we define it. Okay, so that's actually kind of handy because then you can do calculations easily, right? If you know the angle and you know the radius, then you know the arc length, right? So can use however you feel like, right? So s would be r times theta, right? Theta is of course s over r. S is r times theta, right? R is s over theta. Right? I don't know if anyone ever used that, but but you couldn't. So knowing two of them will give you the last one. Okay. Okay. Any questions? Anybody? Yes, madam. Yeah, sure. So, for example, like if you knew that, say the angle was 45, the angle was pi over 4, right? That's 45 degrees. Okay. And you know that the radius is say 10 centimeters. Okay. And somebody says, so you've got this 45-degree angle. You know that the radius is 10 centimeters. And somebody says, what is the, on a 10 centimeter circle, right, 10 centimeter radius circle, if you take an angle of pi over 4, what's the length of the subtended arc? Well, this gives it to you, right? The length of the subtended arc is just going to be the product of the radius times the angle, right? So S is going to be, 10 pi over 4 centimeters. Okay. Right. So, that's about as difficult as this sort of problem will get, right? It's basically given two of the things. What is the last thing? Okay. So, yeah, actually this one has a name. They give us a name in the book. It's the arc length formula. If you want to give it a name. Okay. Another formula that's introduced in the book is called the sector area formula. And it says the following, that suppose you have a circle of radius r, and you have an angle that is theta radians. Then the area of the sector that's chopped out by that angle is 1/2 r squared theta. One half r squared theta. So that's this sector area formula. Okay. Why does that make sense? Why does that make sense? Well, suppose we didn't know that. Okay, suppose we didn't know that and we wanted to figure it out. Okay, you'd say, okay, well, we're going to do this as again a ratio, right? We'll do this as a ratio again, right? A is to the entire circle, right? Area of entire circle. Well, what's the area of the entire circle? Two pi r is the circumference. Area of a circle? Pi r squared, thank you. Pi r squared. Right, so that is to the whole circle as theta is to the whole circle's angle, the angle of the whole circle, so 2 pi. Right? So what does that give you? That gives you that A is going to be pi r squared theta over 2 pi. The pi's cancel off, and you get the 1/2 r squared theta. Okay, so this is not really a remarkable formula. It's just the idea of ratios, right? Okay, so if you forget it, don't worry. It's okay to forget this. You can just figure it out. Ideally, your mathematical knowledge should be stuff that you can all reconstruct. That's probably, maybe that's not completely true, but there should be a lot of stuff that you don't have to remember. Okay, you don't want to be memorizing things like, oh, is it 1/2 or 1/3 or whatever. Just work it out. Yeah, for things like this, you should be able to work it out. Okay. So, yeah. So I think, I think it's, so there's a little bit of physics in this chapter, but I'm going to skip it actually. I think it's more important that we get on to the more, so from a mathematical point of view, the main point of this section is not things like sector area formula or arc length formula, but rather just the definition of radians. Okay, so right, like what is a radian? How do you describe an angle, right? If this is your angle, what do you call it in radians? What I mainly want you to know is that you define the radians as the length of this arc on the unit circle. Okay, so right, what does theta radians means? It means that this if this angle is theta radians, what does that mean? It means that on the unit circle, then this arc length is theta. Okay. And that's what we're going to be using from now on. Okay. So, okay. So let me. Okay. Okay, so now let's go into section 6.2, where we introduce the trigonometric functions. Okay, so the most fundamental trigonometric functions are called cosine and sine. So cosine theta and sine theta. Okay. So what they are they're things that take in angles and then give you back numbers. Okay. So right. So it's some number. Right. These are some numbers associated with angles. So like cosine of pi/2, cosine of pi, cosine of 2 pi, whatever. Okay, so these are numbers associated with angles. What numbers are they? Well, it actually has a very simple description. You take the unit circle, okay, so take the unit circle, and you take your angle, theta, say. And then cosine is the x-coordinate of that point. So you draw a ray at that angle going out and look at the point of intersection with the unit circle. And then you look at its x-coordinate. Okay. That x-coordinate is called cosine theta, and it's usually abbreviated cos theta. Okay, but it's read cosine. And the y-coordinate is what we call sine theta, abbreviated sin theta. Okay, so for example, some some simple ones first. Right, if I ask you the cosine of 0. So I should say that we are always going to start, we're going to start this is going to be our 0 line. Okay, and then angles are measured going in this direction positively. Okay, so 45 degrees would be like this, 90 degrees would be like this, 180. That's really important. I have to tell you where 0 is, because otherwise, what does it mean to talk about sine theta? Okay. Okay. So this is the 0 line. Okay. So what would cosine of 0 be then?
1.
It'd be 1, right? Because it's the x-coordinate of this point. Right? Right? So remember how you figure it out. You say, okay, I'm going to take my unit circle. I'm going to draw a ray in the 0 direction, right? In the theta direction. I'm going to look at the point of intersection, and then that point has coordinates cosine theta, sine theta. Right? Well, the x-coordinate, what is this point? This point is 1, 0. Right? So it's cosine of 0 is 1, sine of 0 is 0. Okay? Right? If I asked you what cosine of pi over 2 was, and what sine of pi over 2, well, you would look at this point. Right? You look at this point, right? You've got your pi over 2 angle, you go in this direction, you look at the point of intersection, you say, okay, well, the cosine is going to be the x-coordinate, which is 0, right? Cosine of that is 0, and the sine of that is 1. Okay. Right, so if we're looking at the cosine function, if we're thinking of this as a function, looking at the cosine function, well, at time 0, cosine is 1, right? At time pi over 2, cosine is 0, right? What about at time pi? What's it going to be? What's the cosine going to be at this point? -1. Who is talking? Ah, yes. It'll be -1, right? Right? Because you just, cosine is just the x coordinate of that point, right? What is it going to be at 3 pi over 2? At 3 pi over 2, you look at this point, and its x coordinate, well, its x coordinate is 0 here, right? And then at an angle of 2 pi, it comes back to 1, right? And you notice that it repeats after that, right? So right, it's gonna go like this and keep on going like that. Right, so it's it repeats. The graph of it actually looks something like this. And then it repeats. Okay. Okay. Sine, on the other hand, right, starts off at 0, right? And then you see that the y-coordinate is getting bigger up to 1. The y-coordinate decreases down to 0. The y-coordinate goes to -1. Y-coordinate comes back up to 0 again. Right? So it's basically doing exactly the same thing, but just with a delay. right, and so on and so forth. Okay. Right, so what you see is that sine of theta is the same thing as the cosine of theta minus pi over 2. Right? You see that one is a shift of the other guy. Right? This guy, if you shift it over to the left, then you get the other guy. Okay. Okay. Main thing you want to get out of this point here is just the definitions of sine and cosine. Okay. Just remember, what is this? What is the cosine? The cosine is the x-coordinate of the corresponding point on the unit circle, right? So just remember, cosine theta, sine theta are the x and y coordinates of the corresponding point. On the unit circle. Okay. That's the main thing that you want to get. If this is your first time encountering them, that's the main thing you want to get. Okay. Those of you who have seen trigonometry with triangles before, I hope you maybe begin to appreciate what the unit circle, right? Because it doesn't make sense to talk about the cosine of 0, right, for a triangle, right, or the cosine of pi for a triangle, right? There's no angle of pi. It's a possible, or angle of 3 pi over 2 or 5 pi or whatever, right? With triangles, it doesn't make sense, but it's very natural for the unit circle. Okay, so main point, the definition. These guys are the x-coordinate and the y-coordinate. Okay. Some observations about cosine and sine. Okay, so first off, cosine squared plus sine squared is always going to be equal to 1. Turn to your neighbor and say, of course, because blah, 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 blah. Okay. Anybody want to tell me why it's true that cosine squared, right? Cosine squared. Remember, cosine squared and sine squared are the coordinates of this point. Amy.
There's a Pythagorean theorem, like cosine is the x and then sine is the y. So like if you look at it in the circle as a triangle, you can take both sides and then if you use the Pythagorean theorem and square them, it equals the radius and the radius is 1.
The radius is 1, right? So you think, well, look, we're going to get x squared plus y squared, right? We're going to get the x coordinate squared plus the y coordinate squared, and we're on the unit circle, right? This is the unit circle, right? So x squared plus y squared equals 1. because that's the unit circle. By the Pythagorean theorem, right? By the Pythagorean theorem. Okay, so this is because we're on the unit circle, right? These are coordinates of a point on the unit circle. Okay, next one, cosine theta equals cosine of negative theta. Sine of negative theta equals what? So let's make this cleaner. Okay, so the first thing I said is that if you have an angle, right, theta, and you look at its negative angle, right, so this is going in the positive direction. In the negative direction, we go this way. Okay, you look at the negative angle. So this is negative theta. And I'm saying that cosine theta and cosine negative theta are the same. Is that clear from the picture? Right? Zoe, you're nodding. Why is it clear? The x values are the same, right? The x coordinate of this and the x coordinate of this are the same, right? Right? So cosine of theta equals cosine of negative theta, pretty obvious. What about sine of negative theta? What about sine of negative theta and sine of theta? What's the relation between them? These guys have the same x coordinates. What about their y coordinates? What's the relation between the y coordinates? Zoe?
Would be negative sine theta?
Yeah, it would be negative sine theta, right? Sine of negative theta will be negative sine theta, right? Because of similar triangles, right? Right? These triangles here are similar triangles, or actually one is the reflection of the other, right? So you know that this length and this length are the same. You see that the y coordinate here is the negative of this y coordinate, or vice versa. Okay, let me put up a couple for you as puzzles, although maybe I've already hinted at them. What about cosine theta and cosine of pi minus theta? Cosine of theta and cosine of pi minus theta. Okay, so suppose you have some angle theta, right? And then you've got pi minus that angle. Well, pi is like this, and you subtract off the angle, right? Right. So if you have a theta here, this thing is pi minus theta, right? This angle here is pi minus theta. What's the relation between the cosines? Or first, what's the relation between the sines? So just remember, sine is the y coordinate, cosine is the x coordinate. What's the relation between the y coordinates? It's too obvious. They're equal, right? They're the same, right? Because you've got this triangle, which is a reflection of this triangle, right? So the y coordinates are the same. Sine of pi minus theta is the same thing as sine of theta, right? But you see that the x coordinates are the negatives of each other, right? So cosine of pi minus theta is negative cosine. Okay. Yeah. Okay, let's, another one, say like, what about cosine of pi plus theta? Cosine of pi plus theta. Well, if this is theta, this is pi, right here. You add on theta to that. So this thing here is going to be pi plus theta. Pi plus theta. And you see that, well, the x coordinates are negative, right? Negative of each other, right? So that's going to be negative cosine theta. And the y coordinates are also negatives of each other, right? So sine of pi plus theta equals negative sine of theta. And let's look at this one, which we figured out graphically, and see if we can think of it from the point of view of the definitions. Okay, if we look at an angle, let's say theta. I'm going to draw it conveniently. So I've got this angle theta, and we subtract off pi minus 2 of it. So we subtract off pi minus 2, right? Pi minus 2 is a 90-degree angle. We subtract that off, and we get this thing, this angle here, right? So, right, the full angle is theta. This guy right here is theta minus pi over 2. Okay. Right. So what you see is that I hope what you see is that this triangle, and this triangle are identical to each other, right? One is just a rotation of the other guy. Let me draw it a little bit more suggestively. So you've got this angle here, and you've got this angle here, right? So this angle is theta, this angle here is theta minus pi over 2. Okay. This triangle here and this triangle here are the same triangle. One has just been rotated, right? One's just been rotated over. Okay. And what you see is that the cosine of theta minus pi over 2, right, is the same thing as the sine of pi. I'm sine of theta, excuse me. Right? The cosine is the x coordinate here is the same thing as the y coordinate here. Right? The x coordinate here is the y coordinate here. The y coordinate here is negative the x coordinate here. The y coordinate here, right? So these guys are equal, right? The y coordinate is negative the x coordinate. The x coordinate of this point. Okay. So anyway, so the point is that you can get all sorts of trigonometric equalities for without much difficulty from the definition, from this definition. Okay, that's it for today.